Okay.
Okay, so we are live.
So should we go to the preparation?
Yeah, so the preparation assignment, number 1, the confidence interval. In October 2008, poll 684 of 1,006 random college students reported that they had been involved in an automobile accident within the last 5 years. So A, find the proportion of surveyed who have been in automobile accidents in the last 5 years. So that would be the formula p hat equals x divided by n. So that would equal 0.679.
Yes.
When you check the requirements, you question the confidence interval for the model. NP hat greater than 10, and 100. How to find the P hat right then 9 then 10. Alright, which you get 63.57 for 3 rounded up to 10. Anyway, it's greater than 10. And you do 10 times 1 minus 10 times 1 minus greater than 10. So the answer is 322.21 is greater than 10. So yes, the requirements are met.
Awesome.
Yep.
Okay, so determine the margin of error for the 95% confidence interval based on the data. So that would be 1.95, 1.96 times the square root of p hat times 1 minus p hat in parentheses divided by n. So I have the it's 1.96 times, so I would do the everything under the square root first, which is 0.6799 times 1 minus 0.6799 divided by 1006 times squared that, and then it's times 1.96, and then I get 0.0288.
Perfect.
Yeah, that's what I got.
So then the confidence interval for the proportion of those who have been involved in an automobile accident in the 5 years, I got 0.651 and 0.709. No, 9. 709.
Very
Wait,
good.
did I do that right?
Mm-hmm. Yep.
Okay.
So then E, how many college students should you survey if you want a 95% confidence interval with a margin of error of no more than 0.015? So the formula would be the number equals the value of 1.96 divided by 2 times the margin of 0.015. So I got 4,269.
Yep. Because you round up.
Always round, yeah.
So, are we back to me? Sure.
Okay. Hypothesis test. Now you're interested in testing a claim that over 60% of all students have been in a car accident within the last 5 years. Use the same information as above and use a level of significance of 0.5. 0.05. Yes. Oh my goodness. I must be tired. Okay, state the null and alternative. So the null is 0.60 and the alternative is p is greater than 0.60.
Yes.
Yep.
Okay.
Would you want me to do B?
Yeah.
Compute the test statistic. Z equals the 0.6799 minus the 0.60 divided by the square root of 0.60 times 1 minus 0.60 divided by 1006, and you get 5.173.
Very good.
Yep.
For C, the p-value was kind of an interesting thing because when I plugged that number into the applet, it like would not go past 4 for me. I don't know if anybody else had that problem. So the p-value it gave me, I mean, it's p is close to 0, but the closest I could get to that was actually was 3.1671 e minus 5. So with the zeros on top. But when I looked at the answer key, it's 1.15 times 10 minus 7, or the thing on my, or 10, yeah.
E minus 7?
So it's close to 0. It's one of those that has the zeros all the way out.
Yeah.
Wherever, but
See,
I don't.
mine is. See, my area I got was 1.1457 e to the 7th.
You were able to get that with the applet?
Yeah.
Yeah.
Why is my
So
answer?
I got 1.1518 e to the 7th.
Oh, really? That's funny.
So do we have? And mine wouldn't let me go past 0.4. That's hilarious.
That's so weird.
So I put in for the z-score 5.174 and shaded the right side, the right tail. Is that what you did?
Yeah.
Yeah.
Huh. Yeah, I got 1.1457 e to the 7th, which is exactly, if you rounded it, it would be 1.15 to the 7th. I don't know. The applet is kind of temperamental, I think.
Yeah.
It is temperamental.
Yeah, I just did it again.
Yeah.
I got 1.15.
Whatever's in the mood to give
I'm
us.
trying it again. Well, we know it's close to 0.
Yeah.
Yeah.
Okay,
it's
I
close
got
to
it.
0.
Okay,
I
so
got
Good.
did you shade?
I needed to type in a smaller number and then shade everything to the right, take everything away, and then put in the z-score, and then it gave it to me.
Oh.
Okay.
Yeah. See, I did the same thing because I was like, "Is that right side shaded in?"
Yeah, you can't even see.
I know it doesn't look like it, does it?
Okay.
Okay.
Awesome.
So then D is reject the null.
Yeah. So we have sufficient evidence.
Awesome.
Okay. You ready for this?
I think we are.
Ready? You're laughing.
My applet will not work.
Oh no!
Delete.
Did you refresh it? Like your screen?
Because it won't let me delete anything out. It keeps the same information. So how do you refresh it? Yeah.
I just I just refreshed the web page.
So there's that little refresh arrow on the page line. Just try that because that would reload it for you maybe.
let's see. I got out and then got back in because I couldn't find refresh. Okay, there we go.
Found out a way to go and try everything.
You ready?
I think
Okay,
so.
are we ready then?
Mm-hmm.
Okay, group meeting 17.
Number 1 and 2 should be true. 3, the symbol for the true population proportion is P. And P hat is the sample for it.
Yes.
Okay.
Right, yeah. Which I kept confusing those two. So
I did too.
Right.
So 3 is C.
Let's see.
I like
Questions.
the tilde over the middle P. That's really nice.
right.
Looks like a little hairstyle. Okay.
For questions,
So for questions 4 and 5, suppose n equals 100, p equals 0.25, and p hat equals 0.10. The requirements for constructing a confidence interval are satisfied.
Okay, so 100.
I would say yes, but
Think so.
Really sucks. So I suggest not getting it.
yes.
Um,
And okay, so let's just check.
Yeah, because we need. Okay.
Yep.
Okay.
The only one where it would be questionable would be and it's exactly 10. So the p hat times 100, yeah, is 10. And then 1 minus the p hat equals 0.9 times n is 90. So yeah, we're good.
But
wait, what did you do?
So you have to do, the first one you have to do n. Let's see, so which is 100 times 0.25.
Right.
25, and then you have to do
The
1 minus 2.5, which is 75 times 100, which gives you 75.
Isn't it times 0.25 instead of 0.2?
Oh wait, 0.25?
Yeah.
Let's see, 100 times 0.25 is 25.
Well, for the second one, what did you say?
1 minus 0.25 equals 75, and then you would times that by 100, which is n. So we get 75.
so are we not using the n times p hat greater than 10 and n times 1 minus p hat?
We are, but you have to do it separately for p and for p hat.
Yeah, so that's right.
I'm sorry.
I thought you said 2.5 instead of 0.25.
I could have, because that's
So
the
I
way
just
my
want to
brain works. So it's a good thing that I have like a safety net to catch that. But I am typing in 0.25.
Okay, good. So yeah, true.
95 would be the requirements for conducting a hypothesis test are satisfied.
Yes. So both are true.
They are?
Yes, because the first one is for the confidence interval and the second one is for hypothesis testing.
Okay.
So you would do it's pretty much the same formula.
Okay.
It's
Let's
pretty much the
see.
same formula except that for you used n times p hat is equal or greater than 10 when you're doing the check for the confidence interval. And then you do n times p is equal or greater than 10 if you're going to do the hypothesis test. But they both need to be greater than 10. So I didn't add the n times 1 minus p hat and the n times 1 minus p is greater or equal to 10, but those are also true.
Hypothesis, we use n times p hat for both, right?
No, n times p hat is the formula that we would use for the confidence interval. And then n times p is what we use for the hypothesis test.
Okay.
The formula is generally the same thing, except that
It's just
you use p hat for the confidence interval and just p for
Just
the
p.
hypothesis test.
okay. I don't know why I don't have that down. Okay, a study of first-degree murder trials was conducted in another state. A random sample of 60 people on trial for first-degree murder was taken. Of these, 45 of the defendants were found guilty. Use the information for 6 through 8. So find p hat, the point estimate of the proportion of first-degree murder defendants who were found guilty in the state. So that would just be 45, right?
Is that?
Are you looking for percentage? Are you looking for percentage?
Yeah, I thought it was going to be.
Equals x over n.
Yeah.
I thought it was still at 0.75.
At 0.75.
Yeah.
Okay.
Oh, okay.
Is that
Yeah.
sound right?
0.75. So that's just x divided by n, right?
Yeah.
Should we put 0.75? Does it matter?
Yeah, I put 0.75.
Yeah.
12% interval. And we have n equals 16.
So if we have
16 and
people, 45 defendants,
45. Okay, so for confidence interval,
Of 90.
0.640 and 0.860.
Yes.
right?
So B. Okay. If you increase the sample size to 80, what would you expect to happen with the width? It will decrease.
Yeah.
I always get that confused with the other part.
With the when you increase the not the confidence, yeah, the confidence,
The confidence interval.
the level of confidence, or the percentage.
Is this true?
So when you increase
So
the percentage.
I just remember if the sample size goes up, then the confidence interval decreases.
Yeah.
Okay.
So sample sizes decrease.
Okay.
Okay, so to conduct a hypothesis test for one portion, two requirements must be met. Suppose P equals 1/2. P equals 1/2. What is the smallest that N can be that both requirements will be met? Okay.
So are we, is that finding the margin of error? Is that what we're doing?
Is it 20?
I got 20 for the first one, but I just want to make sure it should be fine for the second because you're doing 0.5, right? So it ends up being the same.
The second, so yeah, and then this for number 10, it should be 100 since the part on top is a 1. Then we don't have to think that hard because in order for it to then equal or be greater than or equal to 10, we just have to times it.
Let me see. So okay, so then
Yeah, I think it would be 100.
yep. Quick thinking. So 20 and 100.
Can you tell me how you figured that out? Sorry.
Okay, so if you do on the first one, if you turn that into a decimal,
0.50?
you can turn it into 0.50. Actually, I think the way Karina did it, and correct me if I'm wrong, Karina, you kept it a fraction.
Uh-huh.
And then you just need to take the bottom fraction and quite literally just times that by 10.
Mm-hmm.
Place that on the top of the next fraction and then or put 1 underneath because when they times across it'll be 20 over 2 and when you work that out it'll be 10.
What? Sorry, I'm totally lost now.
Let me see. So it's see, can you see that?
Yeah. Why would you time is it? Oh, I see. Hold on. 1.
So when you look at the 2, you'll times that by 10 to get this number here. So then when you times them straight across, you'll get 20 over 2, which will equal 10. Which is the same thing with the next one.
So 1 over 10.
Yeah.
So yeah, so you have 1 over 10.
Why are
And
you?
so then 10 times 10 equals 100 over 1. So then when you times those straight across, you get 100 over 10 equals 10. The one thing that we need to make sure we do is we just double check it when you do the 1 minus
1 minus 1/10 or 1 minus
1 minus 1/10. If it were reversed and you did like when we did the one that was like 4 over 5 and that was 80%, then it actually goes down. So when you actually did the when you actually worked it out, the first number, that's where I got caught up on the homework assignment too, is when I worked through that, I only worked through the first set of numbers, and it would have been 13, but when you work through the second set of numbers, then you realize it's actually 50.
So how did you get the 10? Did you just pull 10 out and the 100?
You're talking about like Like a number like 4/5?
Yes, that was the question was 4/5.
You got 13?
What did I do for 13? It was point. Is that what it was? Yes, because then I did if you do 0.8 times 13, you get 10 minus 4. But if then when you do the 1 minus 0.8, you get 0.2 times, and you times that by 13, and you only get 2.6. So I had to increase the sample size until that second one gave me 50, because that's the lowest that would satisfy the second criteria.
Yes. Sorry, my brain was on a different question. I was like,
No,
what
you're
the?
fine. Like, I don't know what Ruth's talking about. Get her some M&Ms quick. She needs something.
Oh, dear.
Now, you were saying, Manette, how did we get the 10 or the 100?
Both. How do you pick that number?
This number here comes from the question. P equals, on number 10, it says for the hypothesis test, 2 requirements must be met. Suppose P equals 1/10. So we have our 1/10.
Yeah.
What's the smallest that n can be, and to have both requirements still met? So all we do is we take this number times it by 10, which gives us this number up here, and then you turn that into a fraction, and you would multiply them, and then that gives you 10 or 100/10
Equals 10.
equals 10.
I was just wondering how you got the 100, how you pulled that out. But you
Yeah. Yeah, we took that and times that by 10. That just gives us the quickest number that this could divide back into.
Okay.
Then all you have to do is make sure that you check it against the n minus 1 p. I'm writing backwards. And make sure that this number here, still plugs into this formula so that it works.
N times 1 minus p.
You guys
Okay.
having fun?
312.
So are we okay on that one?
Yeah, I think so. Are you guys good?
Then for 11, that one, they are satisfied. Because when you plug it into the thingamajigger, that's the technical term.
The thingamajigger.
They're both,
Into the
they're both greater than or equal to 10.
Awesome. I love that we can use the thingamajigger more now.
Yeah.
It makes life so
So
much
then
easier.
that pretty much gives us the rest of the information for
Okay.
this test. Because then p hat, if you scroll down, it should say 0.475.
Okay, so wait a second. How did you plug that in?
How did I plug them in? So
Right?
you just put in N and X, like it says in these little blue boxes for the one sample V test for
400 points. Yeah, I just got so much of the combos. He used a rainbow Luke.
Oh, I have that. I don't know why. Green rainbow. I have this thing where it explodes and it goes
Does that make sense, Minette?
around the circle. Yeah, let's see if we'll do
No,
it.
then there's this weird thing that flies around and is shooting.
0.475.
Oh yeah, laser.
The X.
Laser thing. I used to have that.
So for 12, 0.475.
Wait, I want to do that green thing again. Wait,
Joe.
I need a couple rounds to come in.
I broke
So
the
should we
system.
I
I will never end. I've faced worse than this.
Can you share your screen? You don't really.
Me? Yes, I can.
Let me-
Yay! Okay. Wait, whoa, oh no. Okay. If I can get back to, go down.
Has decreased.
Okay.
She'll never fall.
Awesome. Okay.
I think they're orange.
Can you see 9 minutes?
You have to, I have to find it again.
We're finally starting to get through.
So-
I clicked the round button like 7
There's
times.
blue ones, red ones,
So got bigger.
green ones,
Yeah.
and red.
So you put in the X right
I
here,
think orange
and then the N,
Wow,
and I just left it at a 95 confidence interval. They give us the null, which is point.
So, Daddy, I'm just gonna throw in all the waves and see
In
what
the
happens.
hypothesis test,
I
they're
clicked it
testing
something
them,
like 17 times.
so it
um,
should be less than. And then it should just pull up all the information for you. We have p hat here, we have the z score, we have the p value,
And I
requirements met.
You have to click on the thing for it to change. I put the information in, it just didn't change, so I was wondering. But now I have a p-hat of 0.475.
Right.
Yes.
Okay.
So then the test statistic is 0.813.
well,
Is that what you guys got?
Daddy,
For what?
what's your favorite number?
The test statistic?
I got negative 2.282.
21.
I've got a negative 2.282 as well.
Let's see if I can survive this. I actually don't know if I can.
What did you get, Kimmery?
Let it lag out.
Wait, so did you get negative 2.282?
Yes.
And down.
Yeah.
Then up and over, down.
Yep.
And then back out.
And then the p-value, did you guys get 0.011?
Yes.
Wait, so what did you say you got for the test
So
statistic?
Negative 2.282.
Okay, yeah, that's what I got.
Okay.
How did you get the p-hat of 12?
So it should just say, so if you put all that information in blue, then underneath it'll say like hypothesis, test requirements, confidence interval requirements, and then the one under that is descriptive statistics. It'll give you N, which is 80, and then P hat, which is 0.475. You see that number right there?
Yeah.
You got it?
But no,
But
it's literally, what it'll do is it'll literally go all the way.
So did you put in the null hypothesis of 0.60 and the type test less than?
What way did you down?
400 and that.
400.
That's died. You died.
21. But no, because it sucked up most of them. I just managed to get past like 11 guys. Just come in here. I'm just gonna leave this up to you.
So is everyone okay on 12 and 13?
I'm just working through it again real quick, so.
Okay. Do you guys still see my screen, or do you see me?
Yeah, well.
I see you.
Oh, okay. I was like, I thought I took it off. Okay.
It's still weird.
475 minus per peak is usually 0.
No, I just went.
What'd you say, Manette?
So the kind of z-score, just take the 0.475 minus the peak, but my p just says 0.
After the 21.
It says 0. Do you have
what?
X
What are you
as
saying?
38, N as 80, confidence level 0.95, null as 0.60, And then the type of test less than? Oh, okay. I was like, well, that's bizarre.
Hmm.
So we all okay on those?
Yeah.
Okay.
So, the charger is in the winter. Just that. Make sure it's I did. I'll check it in a second and then it's done. Okay?
So the p-value is 0.011
Yeah.
Yes.
Which means for
and
15,
50
reject
reject
the
the
null.
null.
Yeah.
Yep.
And then 16,
And
there is
16.
sufficient evidence that it has decreased.
So A.
Yeah.
Yep.
Okay.
Do we want to go through them?
So should we? Yeah, let's just read it through.
Okay. So number 3 should be P, the last one. Number 4 should be true. Number 5 should be true. 6 should be 0.75. 7 should be B. 8 should be C.
8 is
Did I say that wrong?
8 should be B.
I mean B. Good thing I did it.
Decrease.
Decrease.
Right?
Decrease. Decrease. Yes.
We like talked for 5 minutes about it. I don't know what. Okay. 9 should be 20. 10 should be 100. 11 is true. 12 is 0.475. 13 is negative 2.282. 14 is 0.011. 15 reject the null. 16 is A, there is sufficient evidence that it has decreased.
Yep.
Perfect.
You ready?
Here we go.
Okay.
Yes.
Let's do
Woohoo!
Yeah?
Ah, I feel
it. Yay!
good.
Good job.
Sweet.
Thank you.
All right.
Great.
That'll
Good.
bring that nice green arrow going back up.
Yes.
Yes, we need
That
to
arrow.
go back up.
So mean looking.
I know. I covered that green arrow. I shouldn't, but I do.